Okay, we ended the last video. We took A times B, and that equals this answer. Now when we try to divide back, we showed matrix division that when you divide, you're solving this equation. You're solving for x. Well, if we take the answer, my answer being the right-hand side, and A being the first matrix on the left-hand side, then X is supposed to be equal to B. And it doesn't. It doesn't equal. But A times X, we'll call this X, equals answer. There we go. In this case, A times X equals A times B. X was supposed to equal B. But when you multiply things together, X is a solution to the equation. Each row of A is like a single equation. So we have two equations in simultaneous equations. We have two equations, and we are trying to find and three unknowns, three columns. Each unknown is a column. So let's go back to my paint and we'll take a look at this again. The meaning of a matrix equation like this: matrices are especially good at solving simultaneous equations. So this is two equations in three unknowns. The meaning is 1 times x, just like our matrix multiplication that we went through earlier. 1 times x plus 2 times y plus 3 times z. So there's this equation. And we're going to set it equal to some answer. 4 times x plus 5 times y plus 6 times z. 4x, 5y, 6z. It's going to equal whatever we make the answer to be. In this case, we said the answer's got to be 5122. But there's more than one answer to this problem. That's the trouble. You've got two equations, three unknowns. There's an infinite number of answers to this problem. So let's stick with three equations and three unknowns, or four equations and four unknowns, and so forth, because those will have a unique answer. Let's go back to MATLAB now. So clear out the command screen. A equals bracket 1, 2, 3, colon, 4, 5, 6, colon, 7, 8, 9. Now, this is a little bit of linear algebra that's probably beyond you. It's called the determinant, det, of A. It's equal to a really tiny number. Essentially, it's equal to 0. Remember rounding errors and the precision, the smallest precision in MATLAB? This is really, really close to that extremely small precision. It's a rounding error. The determinant is 0. What that means is, when you get to linear algebra, you'll find out more about this. When the determinant equals 0, it means that these equations are not independent. These are more like two equations and two unknowns, two equations and three unknowns, not three equations and three unknowns. There's a unique solution if you have three linear equations and three unknowns, but not if you only have two equations. The fact that one of these equations, you can get one of these by some addition, add, subtract, multiply, or divide of the other two. Some sort of process will give you the third equation. So that's why they say they're not independent. So let's change this to an independent equation. In fact, we might not be able to get a solution. Let's try that. By the way, you can always try stuff. I'm just giving B some random number, and then A goes into B. There. Okay, so this is telling us that this is a solution. This is telling us the same thing as this, that the determinant's 0, that the answers you get are probably going to be bad. Results may be inaccurate, because essentially you have two equations and two unknowns. Let's change A. Here's something else you can do. Now, about matrices. A of third row, third column. First index is row, second index is column. I want to make it equal to 10. I'm going to set it equal to 10. I've just changed A. You can change elements inside of A. You can change ranges of elements inside of A, by the way. You can, for example, add an extra row to the end of A. A of all extra column. Let's make an extra column. A of all of the rows, comma, fourth column equals we're just going to add 0 to the end of that. There it is. Now, oh, I didn't want to do that. Let's back it up. What you can do, this is another trick. This is what's called the null matrix, just two square brackets side by side. This says wipe out the fourth column. Get rid of it. Get rid of zeros, get rid of anything. Just it doesn't exist anymore. We're back to where we were. Now let's try A goes into B. Now we get a unique answer. We don't get any warnings. That's it. Answer equals C. Or I'm going to say my answer again. Just A, or should I make it X? A times X equals B. That's the equation we're solving. Let's see. So A times X, what does it equal? Does it equal B? Yes, it does. A times X equals B is the equation we're solving. The answer, X equals A goes into B. Let's try it the other way around. Let's try B divided by A. Can't even do it. A into B does not equal B goes into A. A goes into B does not equal B divided by A. In matrices, matrix multiplication, matrices are not commutative. They don't work the way ordinary numbers do. So you got to be very careful of the order. Very careful of the order. Key point, very careful of the order. Okay, about the last thing I want to say about this. See, solve simultaneous equations. There's a couple other ways to solve simultaneous equations. One is something maybe you're used to. We're going to make a big matrix equals. You can combine matrices, the commas and the semicolons and stuff like that. You can put matrices side by side. So A, comma B. So this is going to put A on the left side, B on the right side of a bigger matrix. There it is. Now, REF, reduced row echelon form, which you might learn about. There we go. What you'll get is, for an answer, is if everything works right, if you don't get this warning, if you don't have a singular matrix, you're going to get the identity in the first 3 columns and then the answer in the last column. Oh, there it is. Here's the answer. Negative 9.333, 9.667, and 0. Answer, same answer. REF. There's, yeah, so that's another way to solve it. Another thing people do is they'll create A inverse. They'll get the inverse matrix of A, and then they'll do A inverse times B, and they'll get the same answer. I'm going to stop it there.